Hello viewers, I am Kausalya. Today we are going to solve another problem related with reciprocity theorem. The problem is verify the reciprocity theorem for the network of the figure shown below. Find the current in the 3 minus J4 ohm impedance. Right. So here we need to calculate the current that flows through this branch. Okay. 3 minus J4 ohm. So here we are having a voltage source and there are two parallel branches. Apart from that, we are having a resistor. Right. So here the first thing is we are finding the total impedance of the circuit. So how to calculate the total impedance? You see, these two branches are in parallel. Right. So impedance of this branch will be 3 plus J4 and impedance of this branch will be 3 minus J4. So here these two branches are in parallel. So what is the formula to be used? It is Z1 into Z2 divided by Z1 plus Z2. Right. Then that combination of resistor comes in series with this 5 ohm resistor. Right. So finally we have to add the value with 5. That's it. So here the first thing is finding the total impedance of the circuit. So as I said, these two are in parallel. So here the formula is Z1 into Z2 divided by Z1 plus Z2. So once you solve this, here you see finally we are ending up with this answer. Right. So here in this case actually you can skip this step. Okay. No need. Because you see this is of the type A plus B and this is of the format A minus B. So A plus B into A minus B, it is nothing but A square minus B square. Right. In the place of A, I am having 3 and in the place of B, I am having J4. That's it. So just substitute it over here and the final answer is 25 by 6 ohms. Right. Then that combination, okay, now we have combined these two parts into a single one and now this combination comes in series with this 5 ohm. So you have to add 5 to that. So therefore you see this combination of resistor is in series with 5 ohm. Therefore the total impedance is 25 by 6 plus 5. So once you take LCM, here we are ending up with the final answer as 55 by 6 ohms. Right. So now we are going to calculate the current. So the current is nothing but V by Z. The voltage is 550 volt and the value of impedance is 55 by 6. So once you solve, here we are getting the answer as 60 amps. Right. So therefore the total current is 60 amps here. And the next thing is current through 3 minus J4 ohm, because this is the thing we are expected to find. Right. So again when you look back at the circuit, we need to calculate the current that flows through this. Right. So here we are having two branches. Right. So what is the current division formula? It is given by total current into opposite resistance divided by total resistance. Right. This is the formula. So here the total current is 60 amps. So opposite resistance, the resistance which is opposite to this part is this. So 3 plus J4 divided by total resistance, you have to add all these things. Right. So when you use the current division formula here, what happens? Total current into opposite resistance divided by total resistance. So here we have added. Right. So once you solve, finally, the value of current is calculated as 30 plus J40 amps. So this is the current that flows through this part of impedance. Right. Now, first part of the problem gets over here. We are proceeding with the second step. So what is our second step? Our second step is shifting the voltage source to the other end. Right. This is the key thing which we use it to do in reciprocity theorem. So we are shifting the voltage source. That is the voltage source which is present in this loop gets shifted to the, that is another loop, or to the one end to the other end. Right. So here the voltage source gets shifted to this extreme end. Right. Remaining the rest of the thing, they remain in the same place. Now what is the thing we are expected to calculate? we are expected to calculate the current that flows through this part. Okay, actual question is we need to calculate the current that flows through 3 minus J4 amps, which we already did in our step 1. Now in step 2, we are expected to calculate the current that flows through this 5 ohm resistor. Okay, always keep that in mind. Don't get confused with the question. Right. So here again, when you simplify the circuit, since we are having a voltage source here, we will proceed from this end. Right. When you proceed from this end, what happens? You see this branch and this branch are parallel to each other. Right. So just by applying the formula, we are simplifying the things. Z1 into Z2 divided by Z1 plus Z2. So here that gives the answer as this. Right. Now what happens? This combination of resistors, we have simplified it into a single resistor, that is single impedance. Now that impedance comes in series with this impedance. Right. You see this combination have reduced as a resistor and an inductor, and here we are having a resistor and a capacitor and a voltage source. Right. So when you look at this circuit, you see all these are in series. Right. So how to calculate the total impedance? It is enough if we simply add them. Right. So here we are adding. So since here we are having a denominator part, we have to proceed with LCM. Right. Take LCM and just simplify here. And here the final answer is 5.5 minus 2.75 J. Right, this is the value of total impedance here. So the value of impedance is 5.5 minus J, 2.75. Then the next thing is we are calculating the current, right? That is total current. Okay, you can just even skip this. Total current is V by Z. So we know the value of V, we know the value of Z. So just calculate. Here the value of current is 80 plus J40. Right. Now again we have to use our current division rule. Now we have to calculate the current that flows through this 5 ohm resistor. Right. So here the value of total current, the total current that flows is, it is nothing but 80 plus J40. Right. So we need to calculate the current that flows through this 5 ohm. So we have to apply the current division rule. So total current into opposite resistance divided by total resistance. Right. So here total current into opposite resistance divided by total resistance. Again here just substitute the values. Right. Here you can just multiply by using calculator. Okay, it will be much more easier rather than solving manually. So just calculate it, and here finally the answer is 30 plus J 40 amps. Right. Now we can check this value with the value what we get in step 1. So in step 1 the value is again the same, right? 30 plus J 40. So once we are getting the same value for both the cases, then we can simply say the reciprocity theorem is verified. Right. Here comes the end of this problem. If you have any doubt, let me know in the comment section. Thank you.